Good morning, everyone. I'm Houston Cantwell. I'm a senior resident fellow here at the Mitchell Institute, and I am absolutely thrilled to be moderating today's discussion on the topic of electronic warfare. This mission has long been a game changer since World War II, and every day becomes more important. But in the past 3 decades, often driven by hard budget choices, the EM spectrum operations, or EMSO, fell short and below the cut line, below the Air Force budget, as well as across DoD. Not only has this negatively impacted technology capabilities and capacity, but most crucially, our ability to develop our personnel. EMSO operations are not a pickup game. We need a deep bench of highly qualified operators with the mindset, understanding of the spectrum, and the tools needed to fight and win. Anyone questioning that should consider what's happening in the Ukraine, what's being planned in PACOM. Make no mistake, when it comes to great power competition, EMSO is the key to operational success. That's why Secretary Kendall included this as one of his cross-cutting operational enablers. We certainly applaud that here at the Mitchell Institute. To discuss not just why EMSO matters, but also how the Air Force is looking to achieve non-kinetic electronic effects on the battlefield, I am thrilled to introduce 4 experts on our panel. Today, I'd first like to welcome Colonel Larry Fenner, commander of the 350th Spectrum Warfare Wing. Next, I'd like to welcome Chris Moeller, Air and Space Force Customer Requirements, BAE Systems. Next, I'd like to welcome Nick Bucci, Vice President, Defense Systems and Technologies, General Atomics, EMS. And finally, we are also happy to have Paul DeLia, Director of Advanced Technologies, Airborne Combat Systems, L3 Harris. Thank you, gentlemen, for being here. Okay, similar to the last panel, we're going to take about 45 to 50 minutes, and I've got some prepared questions, and then we will open it up to the public. Okay, to begin with, Colonel Fenner, we'll start with you.
Okay.
I did my best to highlight the importance of the EM spectrum, but let's be honest, you are the expert. I'm a knuckle-dragging F-16 RPA driver, and knowing that resources are always tight, why is it critical that the Air Force continue its renewed focus on EMSO operations? I mean, given that we're in the information age, I'm guessing that effects in your community can deliver effects in the battle space that are more important than ever.
Well, thank you. I appreciate being able to come out here and speak on behalf of the EMSO enterprise. Just want to say thank you to General DeLia, as well as the Mitchell Institute. Any opportunity where the 350th Spectrum Warfare Wing can get out there and articulate the message of the EMSO enterprise is a great opportunity. As I have seen the enterprise grow from a baby crow, and I am pleased to see where the direction of the EMSO enterprise is going. And to you, General Cantwell, I'd just like to thank you for moderating this panel. But to put it simply, for combat EMSO operations, simply put, we'll lose. I believe General Mark Kelly, former ACC commander, he put it best. If we lose in the spectrum, we're going to lose the fight in the air, and we're going to lose quickly. Our adversaries have developed the organizations, the professionals, the capabilities, the tactics, techniques, and procedures to outdo us in the spectrum. And it is the job of the 350th Spectrum Warfare Wing to make sure that that does not happen. And so we are aggressively approaching how we take the electromagnetic spectrum and put it squarely in our corner. Thank you, John.
Thanks, Colonel Fenner. Let's turn our attention to combat operations in Ukraine. So taking your perspective into context there, Colonel Fenner, to our industry partners, there's no better learning lab than the real world. What are your main EMSO-related observations when it comes to everything going on, the combat ops crossover in Ukraine? Chris, we'll start with you.
Yeah, I'll start. First, I want to also thank the Mitchell Institute for bringing us together today. Being on this panel really is exciting for me because it kind of had two things I learned in my Air Force career that I really like doing, and that's one, trying to solve hard problems and listening to really smart people solve hard problems. And I also learned as a fighter pilot that I really like to hear myself speak. So I'm really happy to be on this panel today. When we look at the Ukraine problem, one thing that I think is interesting is it shows that the cost of entry to degrade and disrupt in the electromagnetic spectrum is actually relatively low. We have some very high quality, exquisite electronic warfare, electronic attack systems in the military. But with the dual use capabilities that we've seen in the Ukraine fight, whether that's through navigation or communications, those capabilities being commercial systems are relatively easy to modify and change, strap onto a low-cost drone or other system, and start to degrade and disrupt the electromagnetic spectrum, forcing either side, who's ever being attacked at that point, to find other ways to operate. So the cost of entry is relatively low. Now, to do it well and to hold and maintain electromagnetic superiority, that takes a little bit more work. And we'll talk about that throughout the panel, I'm sure, with the electromagnetic battle management, the need to modernize. But why does it matter? Well, for us in industry, we want to try to go fast, and we want to use, where we can, use commercial off-the-shelf technology. However, if you rely solely on that technology, you find yourself in the situation that they have in Ukraine, where it's easily modifiable and can be degraded and disrupted relatively quickly for relatively low cost.
Thanks, Houston, and thanks to Mitchell for having us here today. It's a very important topic, as well as all the other topics as we look forward to what we're going to do from an Air Force perspective as we go forward. So from my perspective, from a spectrum management, we have to take advantage of all of the spectrum. And we have to look at if there's multiple phenomenologies that we can use to communicate, we should do that. You know, we are finding that precision munitions are being denied in Ukraine. I don't know the exact number, but it's a very high number in terms of denial of precision munitions in Ukraine. And so we need to look for alternative methods, and maybe some of that is using other types of spectrum rather than GPS and RF. I mean, maybe we need to use optical and things like that. So I think that's one important point. The other is, as Chris mentioned, I think it's important to, I use the word exploit, but probably not exactly the right word, exploiting the civil spectrum, using what's there for survival and defense, as well as offense when you need to for strike operations. So it's kind of playing both the defense game by using the rest of the spectrum, you know, that which isn't being denied, as well as taking advantage of the civil spectrum because you can, because that's not necessarily being denied.
I just want to add my thanks again to the Mitchell Institute for having us here. It's a very important forum. To your point, sir, I think my colleagues here pointed out the use of commercial capabilities in the warfighting environment, and true that those capabilities are available to everybody, and the key to making them operate well is the software and software enabling them. Thankfully, in the United States, we have decades of EW experience, and we have these subject matter experts in order to enable those commercial systems to work well in the environment. But in Ukraine, just using one example with respect to GPS jamming that the Russians are doing, is a good news, bad news story, right? The GPS jamming is effective, but they're also subjecting themselves to a lot of electromagnetic fratricide. So how do you handle that? What is the theme of the story there is, how do you use information, how do you use data to deconflict and do that electromagnetic battle management in near real time, rather than with a bunch of Excel spreadsheets, or worse yet, a big cheap writing tablet and a number 2 pencil. I think that's going to be a very key aspect, and one of the key lessons that we're learning in Ukraine. You know, the Russians have their Radio Electronica BORPA, their version of electromagnetic warfare, and they're combining that REB with tactics in order to gain effectivity against the Ukrainians. And the Ukrainians are getting very innovative with using commercial off-the-shelf technology in countering that. So we have this do loop of countermeasure, countermeasure going on in near real time, and that's going to be key to our future fights as well.
Yeah, Paul, I couldn't agree more. Also trying to determine, is it mutual interference? Is the enemy actually actively trying to do this? How do we differentiate? When I was flying the Viper, the one thing I always do when the link wasn't working or the radio wasn't working is turn it off, turn it back on, right? I mean, I like to think that we've gotten more sophisticated in the last 10 years, but I think it's been a slow evolution to get to what you're talking about. So fantastic, thank you very much. Okay, let's turn our attention to PACOM, the Pacific. Are there any trends? You know, we're talking about Ukraine, smaller scale conflict. When you go over to the Pacific, it's a much larger theater, different EM spectrum considerations. Anything that you all have thought about, you turn our attention to the west.
Sorry. I guess one major thing that I see is in Ukraine, we're talking about air, land, and in the Pacific, we're talking about air, sea, and land, but in a lesser degree, certainly than Ukraine. So that is definitely going to introduce significant differences in, I'll say, the challenges and the threats from an electromagnetic spectrum perspective. You know, maybe the exploitation of civil things like what the Ukrainians are doing with a cell phone app to be able to track UASs as they fly into Ukraine. Maybe that's not going to work because most of the path may be over water in the Pacific. And so I think there will be some new challenges and new threats. And, you know, as we've talked about so far, I think the fact that we need to move fast and utilize capabilities that we've been thinking about for a long time, but we're now going to have to use them in that kind of environment.
I think the subject of this particular panel is something relevant to what you just discussed. In Ukraine, we're seeing it's a very tight fight within a landmass, and obviously Indo-PACOM is much larger. So what is that proper balance of kinetic and non-kinetic effects in order to achieve superiority? How do you electromagnetic battle manage and develop COAs in order to maximize our magazine depth, because that supply chain is going to get stressed. So that's, I think, a major thing that we in industry, and I'm sure obviously the DoD is looking at.
Something else that BAE's been kind of looking at is what China knows that air power is inherently offensive. I think someone much smarter than I said that a little bit earlier. Air power is inherently offensive. So what they've done is they've taken their coastline and essentially pushed it out as far as they can by tying together through an intricate web, weapons, ships, aircraft, space, everything they can to develop this redundant web to where low-cost commercial off-the-shelf solutions may degrade one area, but they continue to operate with a very effective web. So now we are going to have to find ways to make sure our air power remains offensive by finding those areas, the key nodes of that kill web, to be able to push our air power far enough forward to where we can achieve desired weapons effects. And that's where the electromagnetic spectrum exploitation becomes so important. Capabilities like the EA-37B, and the compass call today in the EA-37B that can actually deny key areas of that spectrum, key data links, key communication nodes that they're using to create those pockets of what we call electromagnetic superiority to allow us to then gain air superiority in that region also become incredibly important. Self-protection capabilities like you see on EPOS, F-35, F-22, all of our advanced aircraft today, allowing them to move a little bit further forward by breaking that kill web and forcing the adversary, China in this case, to operate alone and afraid, right? They need to turn their radars on. They need to try to use their own internal organic kill chains to find and fix and engage us. And so that's what we see as most important over there, is to push that coastline back to something that's manageable, to where we can find that correct high-low mix of weapons and high-low mix of aircraft, because we've gained electromagnetic superiority in certain areas.
Yeah, no doubt, Chris. That's going to be a challenge, rolling that back, and the EM spectrum is going to be key to allowing us to do that at a lower risk. Thanks.
In general, I'll just add, so just coming from PACOM, the tyranny of distance issue will be significant, especially for the 350th Spectrum Warfare Wing when it comes to data wrangling. How are we going to get that data back from the forward edge to make sure that our folks can do the analysis and the exploitation and re-engineering to push it back out to the warfighter? That's going to be a difficult problem, especially when you're in a dynamic, contested environment. How do you move that data or get the folks out there that will be able to pick up that data from the aircraft, or is there a way to have an airborne node that passes that data back to rear echelon? These are going to be difficult problems as we try to update the electromagnetic operating environment to what that new baseline is as new capabilities come out there or new modes and new different solutions are being brought out there. We got to be able to get that data back so that we can update the entire force, and that includes our partners and allies.
Yeah, no kidding. You don't appreciate the tyranny of distance till you've flown to Tokyo, and you know.
I just wanted to add to the Colonel's point, and that's kind of going back to what I said earlier about multiple phenomenologies. You know, to your point, Colonel, we got to get that data there, and you know, SDA is forming this network in the skies of satellites using interconnected optical communication terminals. We got to get that from space down to the right, either air asset, ground asset, surface asset. You know, we need to be able to communicate again through that phenomenology. If the RF is denied, use the optical, because that's a lot harder to deny, and I think that's an important piece as we start to get that multi-domain optical communication capability online.
Gentlemen, one area we have not heard a whole lot throughout Ukraine is directed energy weapons, operational lasers, if you will. Here in the U.S., we've seen promising programs come and go over the years, but often they never come to fruition. What's keeping these weapons from being fielded? What impediments do you see within industry or the impediments within the Air Force? How can we help bring these directed energy weapons to the warfighter?
I guess I'll start that one. I think that everyone always talks about directed energy weapons as being 5 years away, and I think mainly that's because everybody is always looking to chase the next level of capability in those kinds of weapons. We're never satisfied with a 50 kilowatt laser. We want the next 50 kilowatts to get to 100 or 150 and beyond. And I think what's required is some level of strategic patience on implementing these weapons. Rather than biting off big chunks constantly and looking for chasing that extra sets of kilowatts or the extra couple percent of beam quality, field it, learn something from it, let the industrial base and the supply chains develop along with it so that you don't get those challenges when you need to go to the next level of capabilities. And I think, you know, having the patience to be able to fight through that, but utilizing each level of capability that can be fielded, get it fielded, and do something with it and learn from it, rather than, you know, let's go for another big bang step as we move forward each time.
So you're seeing programs get stopped even before you can start the next one.
Exactly, yeah, and it's, you know, for many good reasons they get stopped. But again, if you think about it, we need to think a little bit more long-term sometimes to be able to actually get to fielding and get the right capability at the right time.
Paul?
Yeah, so I think it's great to see some of these capabilities, particularly in the RF and high power microwave domain, come out of that trough of S&T and starting to see some level of fielding. And given, especially when we talk about counter UAS class 1, class 2, there's a level of effectivity there. The struggle with some of these systems is really the amount of energy that's required, and then the amount of RF or microwave fratricide that can be caused by having these systems in the field. I think these are all very solvable problems requiring, essentially battle management of these systems. But to my colleague's point, right, get the stuff out there and start learning from it, rather than trying to continually to platinum plate this stuff until it's, it's ready. And you really need to get it out there, get field experience, and understand from that field experience in order to get that next rev out there quickly.
And I think, it's been mentioned a couple of times today about base defense. They are great weapons for base defense, because if I'm, especially against the Group 1 through 3 UAVs and some of the cruise missiles that we've heard about, those are great weapons for those specific threats, because, and especially protecting an airbase. So I think, that may be a great first step into, the Air Force providing that capability for itself as it transitions.
Okay, we're going to change the subject just slightly. Effective EMSO requires close and rapid collaboration between the military and industry. I think you all mentioned that in one of our previous questions. As you've highlighted, the threat picture is constantly shifting, and we need to change with that picture. I'm not talking days or hours. I'm not talking just days or not weeks or months. You need to get this down to days, hours, even minutes, because that iteration between industry and the warfighter's got to be able to handle the updated threats. I remember when I flew the F-16, the ALR-56, we would update the mission data file. I think it was like a semi-annual kind of thing. I mean, it was months. It was a very long time frame. What can you all say about that important relationship as we evolve into the 21st century combat?
So since you mentioned the ALR-56, I'm going to have to jump on that, showing my age here, but I was one of the designers of that system for the Viper, so guilty. And it was probably an annual thing back then. Still using EWARE, right? And then EWARE is informed by other sources on the Title 50 side. So one of the challenges to getting things done quickly is really getting Title 50 information into that Title 10 world as fast as possible. Some of those sensors see things that our Title 10 sensors can't see, and those do help inform rapid decisions. We had the honor of being at Rapid Raven just a few weeks ago and saw firsthand how that can help. I think the other side of the equation, respectfully to all the fighter pilots, I think we need to move from dogfighting to data fighting. In the data there's gold, and being able to leverage that data in real time at campaign speed is really key to getting to what the colonel wants to get to, which is 24 hours or less for threat reprogramming. So the partnership with industry is on understanding the systems that are out there, whether they are the legacy systems or the newer systems, which are more amenable to being software defined and actually reprogrammed in situ via data links and the like. It's that partnership between industry being able to understand what goes in those systems, as well as what industry is doing in the areas of artificial intelligence and machine learning to speed up the sensorization of the data, to the warfighter.
So, General, I couldn't agree more violently about that one, because, wow, data is truly the weapon. If we expect to be able to adapt at the speed of relevance for the warfighter to be able to be lethal and survivable in the airspace, data will be the key. And that is why we are focusing on crowdsourced flight data, being able to get that information from the forward edge and bring it back with the data architecture and the transport layers that can go through the multiple levels of security that will allow us to get that information back to our engineers, to our experts. They'll be able to re-engineer that data and get it back out to the warfighter so they can sense, ID, locate, attack, and counter the threat that's out there. And it's going to be absolutely key. And we have to do it at a speed that is going to be relevant to the fight. So one of the things I know my predecessor, we were touting how fast we can go, but I'm a firm believer that we can go faster. But I need to work with industry and find some of the tools that will allow us to go faster, specifically speaking to automation, because we have a lot of manpower intensive processes that if we insert automation, it will allow us to go faster, cut out some of the manpower intensive hours that we have to put into going through the data. If I can just simply filter it out from the baseline that the intel community gives me, and it can detect the anomalies, that allows me to go quicker. So now my engineers know exactly the targets they need to go after to start doing their engineering processes.
So once you get that data, how do we get it into the systems and get it useful to the warfighter quickly? And there's really three things that us in industry need to build all of our EW systems to. And one, that's the open system architecture that we've been talking to forever, but it's working. It's out there now. The latest Compass Call software and it's going on the EA37B is running 20 plus third-party apps, right? BAE Systems builds the baseline, and then anybody who brings an app, whether that's industry, someone else from the DoD itself or from a university, let's run that app on the system. So that open system architecture is key to getting that data fielded quickly so you don't end up with these individual systems that all have to work separately. Next is software-defined radios, which is a word that always made me chuckle a little bit when I was in the Air Force, because any computer can just be called a software-defined radio, right? You can kind of tack that on anything. But what do you really need in that? You need a radio that's a software-defined radio that's ready for rapid capability insertion and that has capacity to grow. I can't bring you something like an iPhone today that has no room for extra apps because you only bought the 16 gig iPhone, right? So it's got to have that capability to grow as well, as each of these apps, as the adversary evolves, are going to become more and more complicated and need a little bit more data processing power, right? So you got to make sure it's got room to grow. And then finally, you want a modular system that's not just built for the F-35, but something that can come off of the F-35 and be reutilized on F-15 EPOS, which is something that BAE is doing, right? Same systems being used on both of those. Something that can be scaled to a smaller form factor. So really what you need are systems that are platform agnostic, and you can use them across a wide variety of systems, whether that's from CCAs into airborne platforms. When you combine those three, open systems, software-defined radios with capacity for rapid capability insertion, and modular systems, you end up with the ability to take that data and get it across your enterprise really quickly. So you don't have to wait a year for the F-15 to get upgraded, because you had to first go upgrade your F-15s, and then your F-22s, and then your B-1s, because that capability is across all of those. And I think that's something that all of us are working on really hard to make sure every system that's out there has those attributes.
If you don't like software-defined radio, I'll offer, how about zero swap upgrades? So no size, weight, and power impact, because that's something that we've talked about in space for a while. Why not apply that to our weapons and our aircraft, where I'm now upgrading software to provide new capabilities because I can. And I think, Colonel, you bring up a great point about the multi-level security. I think it's important, though, as we move further into advancing our machine learning capabilities across government and industry, that we should be able to do that faster and automate it so that the data can come right from those Title 50 sensors and get into a Title 10 with all the appropriate stripping out of whatever needs to be protected being done automatically, and you get that multi-level security built right in, so now you can get that right data to the right place at the right time faster than you could before. So I agree with you 100%.
So I think we've identified some policy hurdles as well as some technological hurdles to try to empower you to do your job even better.
I think one, to that point, Houston, I think one that is important is certification. You know, as we bring on these new capabilities, they got to go through a certification process and training. And we've got to figure out ways to be able to do that faster. And I think there are ways to do that, you know, through things like digital twins and modeling and simulation, that you can get to that first flight faster and you can get to that certification faster. But to your point, you know, there are a lot of other things that we need to worry about.
Yeah, thank you. Chris, you brought up the importance of software-defined open architectures. Obviously, your company is working very hard on that. Gentlemen, was there anything you wanted to mention, efforts going on within your respective companies to help provide that capability?
Yeah, sure, Houston. I think, you know, what we're doing on L3 Harris Airborne Combat Systems is really no different than anybody else in industry, especially involved in electronic warfare. You know, we adhere we have adapted an agile program, you know, ethos throughout the enterprise, but then we leverage what the DoD has asked us to do, which is, you know, adhere to open mission standards, MOSA, WOSA, big iron compliance, et cetera. And those things are highly enabling for the warfighter. We talked about leveraging different apps on the E-37 as an example. If I develop a big iron app for an electronic attack sequence, right, that can, because it's big iron compliant, 37 is big iron compliant, that readily gets adapted to a place that, you know, to a place of what the Colonel's talking about with, you know, getting things out there quickly. That standardization really helps and helps us provide capabilities, you know, at campaign speed to the warfighter. Combining that with digital twins of systems, it'd be great to have digital twins of all the legacy systems as well. I don't think there's enough money in the budget for that, but combining that with digital twins of systems helps you get things out there even quicker, because now it could use model-based systems engineering and test to rapidly iterate what I develop on that digital twin before I get it out in the field and know that it's going to have a level of effectivity that's positive in the fight. Thank you.
Okay, Colonel Fenner, back over to you. Our traditional ranges are struggling to replicate the complexity of modern EMS environments. How is the 350th Wing working to create more realistic EMS training environments? And can you discuss any specific plans for improving live virtual constructive training for EMSO?
So that's a great question and very timely. We just stood up the 950th Spectrum Warfare Group, and that is the group that is going to specifically get after our EW assessments, whether it's in the live, the virtual, or the modeling and sim constructs. That's where we're going to make an aggressive push to identify where those gaps and seams are, whether it's in our training, whether it's in our capabilities, whether it's in our tactics, techniques, and procedures, and highlight those so we can report those up to higher echelon. Because at the end of the day, I'm not part of the acquisition process, but I have a lot of sway into what is a capability that is either faltering and not providing the capability we need, or hey, we need a little bit more in this particular area to close this particular gap and seam up. So in the live construct, I will tell you, it's difficult. I mean, we have an adversary that's out. We have adversaries that are out there taking a look at us when we're operating live. They want to collect on us so that they have their own databases to basically counter us when we actually get into a kinetic fight. So how do you do that? How do you train in the cockpit and provide that warfighter the training that they need? That's going to be difficult because the more you build up your ranges, you can put overhead and things like that to collect on these particular ranges. So for me and my team, we're taking a look at augmented reality. How do I insert that particular combat scenario into that cockpit without leaking out what information I'm actually training against, or I have the information radiating out of my aircraft so my adversary never can collect on me. But we get quality training for our warfighters to operate in that environment. For the live construct, for the virtual construct, for a joint simulation environment, that is going to be key for us for testing newer capabilities as they come online. And that is one of the mandates I have pushed for the 950th Spectrum Warfare Group, is to go take a look at the JSE and see where we can introduce better capabilities to get a better, I would say, the truth data on how well our systems are operating within that environment. Because if we're not truly training like we fight, because we're not turning systems on, we're not training against specific threats, then are we truly prepared for that pacing challenge threat? And we're also looking at the modeling and sim construct. So gone are the days where we take a system and we put a couple of testers on it and we introduce it 1v1 against a threat. That's not how we're going to fight. And that is not the environment that that system is going to operate in and provide defensive capabilities or offensive capabilities for that warfighter. It has to be a many-on-many dynamic capability that has truthful red data from the intelligence community to make sure that that system is radiating, and then true blue data in that system so that we're not missing things because of classification levels and things like that. We have a true representation of what that system is going to do in that warfighting scenario and get the truth data. Thanks.
This is some of the best news you could give industry, right? Because now we have the ability to go faster because we have the modeling and simulation capability to do it, and we want to help with that. And we also have the ability to do it at a lower cost because we can now run it through a lot more modeling and sim before we start going through live fly and live development. So this is something that's been missing for a very long time and has driven to higher costs and less, I would say, less trust by the warfighter in their electronic warfighting systems. It's kind of an add-on in your tactics and techniques to where you go, I will also run some EW, but I'm going to run my tactic based off ranges and the weapons I have because I don't know if it's actually going to be working. So if we can build that trust in the virtual construct, in the virtual environment, then suddenly these systems become something that is not just an add-on, but is driving our tactics techniques because our warfighters can rely on it. So thank you for doing that.
I think an additional thing to take note of is that if we look at what's going on in 5th generation wireless and now 6th generation wireless that's being planned, part of the underpinnings of those technologies and those capabilities are multifunction. Having an aperture that can do multiple things at once. And this plays, so we can advantage that as industry for the warfighter because this plays exactly what the Colonel's talking about. If you're going to do something live, you want to emulate what's going on in real world to the highest fidelity possible. So it's not just enemy radars are out there, but there's also their commercial wireless traffic, data links, comms, and other things that are out there. And you want to be able to do that in a cost-effective manner and do that in a software-informed way. So we talked about the EMSO data before, but getting that information from the collector directly to the aperture for simulation, right, gets things done very, very quickly and provides a level of realism that really couldn't be afforded, up until now.
I think distributed modeling and sim, distributed digital twins that are connected, and I like your point, Colonel, about wanting to do that not in a range type atmosphere so that your enemies can exploit data collects by doing it, I'll say, in the laboratory. I know that's not a good word to use, but doing it more in, I'll say, on land and moving that data over very secure links so that they can't be easily tapped and taken advantage of, I think is very important. And now having that capability for all of the systems to have digital twins, including the enemy systems, I think would be very helpful in terms of that, full exploitation and taking advantage of to get to the training capability.
I'll just add one more point, and it's back to a point that was made, warfighter confidence. That is something that is key that we're looking at in the 350 Spectrum Warfare Wing. We want our warfighters to have confidence in their systems. And the way that they get that is they actually go out there and train an environment and see how their systems are operating against these threats. When they see that, and they see how well their systems are performing, or they see where there may be interruptions in the system, there is a better process, because there is still a human in the loop that comes in contact with these systems. So if we bend a pin, that can degrade a system. If we're using an outdated operating system, that can open it up to potential cyber attacks. So we're developing that confidence as well and teaching the warfighters about the EMSO environment, how dynamic it's going to be, how contested and congested it will be. Because we also have things like electromagnetic interference that we have to take into account as we're out there operating. So we're not only just going into the capabilities and the systems, we're educating the warfighter as well, so they can have a better understanding of that electromagnetic operating environment, and they truly are. It won't just be me out there being the professionals. It'll be the individuals that are sitting in those cockpits that understand how that environment is evolving and be able to get that data back to us.
Yeah, Colonel Fenner, it's great to hear you leading the charge on LVC. Have you guys been deliberate about ensuring our allies and partners can also be a part of this conversation?
So that is one that we're actually working on a lot better, because Rapid Raven, we did do an iteration where we had our allies and partners, specifically the UK and Australia, participating in that exercise with us. But I think we can do better. I think there are ways that we can incorporate them more when it comes to information sharing, but there are some policy restrictions there. But if there's opportunities where we can train together, because we're going to fight together, we're all for it, and we're trying to get after that aggressively in the 350 Spectrum Warfare.
Awesome. Thanks, Colonel Fenner. Okay, we've also heard the 350th is working on integrating AI and machine learning into EMSO. Industry is obviously moving toward integrating AI into warfighting as well. Can you all explain how AI is being applied to analyze and respond to the massive amounts of signal data that we're collecting during these missions, gentlemen?
Sure. So we talked about moving from dogfighting to data fighting, and and we've also heard terms about swimming in sensors and drowning in data. Artificial intelligence, machine learning is just one of the ways to kind of reduce that pile and get things out to the field quicker. Within industry, we're using machine learning models to do things like radio frequency fingerprint, specific emitter ID. You've heard the terms cognitive EW. Those are all underpinnings, and they're all underpinned, by the technologies of artificial intelligence and machine learning. But it also goes beyond that, right? There's we talked about how dense the electromagnetic environment is going to be in Indo-PACOM and other areas that we may have to fight in. And that's just based on where commercial wireless is going and the public's insatiable need for streaming Netflix or whatever on their phones, right? So that drives the importance of computational electromagnetics in order to make things less attractive, let's say, to enemy radars and the like. Those things are very computational intensive, But through the application of the appropriate machine learning models, you can reduce the amount of time you need to get answers. So those are just some of the ways that we're using artificial intelligence and machine learning. At L3 Harris, we actually announced a strategic partnership with Palantir recently, and recognizing that the sort of the yin and yang between sensors and data and artificial intelligence as it applies to command and control to C2. And if you take that construct further, using artificial intelligence to underpin your C2 actually helps with the code development and the EMDM that's required, to be lethal in the fight. Over. Awesome. Thank you.
Yeah, I think EW is the perfect place for implementing AI and ML. It's always been a cat and mouse game. The enemy develops a new radar, a new comm system, and we understand what it does, and then we take a while to then counter it. Well, if I can do that by sensing and feeling the new capabilities that they're putting out there and adapt much faster, in some cases real time, so that I can then put out a new capability right away to counter it, wow, what a game changer that is. So I think it's extremely important that we figure out how to utilize the commercial advancements in machine learning in classified environments, because these will all be very classified kinds of applications. And to the earlier point about Title 50 versus Title 10 and multi-level security, we got to figure out how to do those again in that same AI/ML situation.
Yes to everything, and because I like to hear myself speak, I'll go as well. So I also was a knuckle-dragging Viper driver, but had the pleasure of spending some time in a distributed common ground system, DCGS, watching some ISR missions at one point in my career. And watching this floor full of airmen process data reliably and consistently over and over and over and get it to the right place where it needs to be was one of the most impressive things I probably saw in my career. So when you start with that end game, with that end user and work backwards and figure out how can we make AI, ML do some of those same things that those airmen were able to do, but at a much higher capacity. That's where we need to start, and that's where BAE, with the Mitchell Institute, has also had some work on talking with some of the endgame users, someone in the battle management career field, and say, hey, what's useful to you? What do you want this final picture to look like? Because we have some incredible engineers who can develop some amazing stuff, but if it's spit out in a format that you can't use, it's not worthwhile. So when we start thinking about electromagnetic battle management, and we want to put this on, say, an EA-37B, where someone airborne is going to be processing this, analyzing this data that is, reading the data that is handed to them that's been processed through AI/ML, what does that need to look like for them so that it is, one, reliable, and two, useful? And once we make systems that are reliable and useful, then, like we talked about with trust in your electronic warfare systems, the warfighter will start using that and will be confident with it. When we say AI/ML, there's always a little bit of hesitancy. We don't necessarily want the machines running the war, but once it becomes reliable and useful, or reliable and consistent, like those airmen that were on the DCGS floor, suddenly they start asking for more and more and more. And now our electromagnetic battle management that's going to be happening in real time so that we can find and fix those nodes so quickly to gain that EM superiority becomes at a rate that we haven't seen before.
Awesome. So when it comes to cognitive EW, I just don't see that we're there yet. When I say we're not there yet, we don't have components on aircraft that can sense the environment, be able to, if it happens to be a war reserve mode, be able to adapt to it, be able to create a waveform, and be able to do everything that we have to do rear echelon on the fly in the air. That's ideal, but we're not there yet. But what I do see, and my team sees, the use of cognitive EW for the 350 Spectrum Warfare Wing is the data piece, because a lot of the AI, a lot of machine learning, that's going to require data. So where we see the potential insertion of AI and machine learning is in that data architecture. As I said earlier, how do we go faster? Well, if I have a machine that can take petabytes of data and basically identify all the anomalies and get that into another process that is automated, that starts to break out that particular signal, where it can now go into another automated process where waveforms are now being generated against that particular threat, and not have hours and hours of manpower, pouring over this particular one signal, but I'm being able to do it at scale with hundreds of signals. That, to me, is game-changing, because now I can adapt quickly to that environment and get that back out to the warfighter at the speed of relevance for that fight.
Chris, you mentioned EA37B a couple times. I want to open it up to everyone. Fielding of our EA6B plus 5th gen types like F-35. Seeing a new injection of EW capabilities at literally a game-changing level. I'm guessing B-21 and CCA are going to continue to advance this conversation. Can you all please help me understand why do you think this is so important as we continue to move into the 21st century?
So none of this is new, right? The Compass Call became operational in 1983. The F-22 with its advanced EW system, our first real 5th gen platform, became operational in 2004, and the Growler was operational in 2009. What's different now is two things. One, the capacity that you're going to see for advanced EW systems. F-35 is going to eventually outpace F-16 as the largest aircraft in the fleet. You have F-22 with its EW. You have F-15EX EPAWS, which is a remarkably capable system as well, as Tess has recently shown. So there's now this, and then EA-37B and its advanced systems and its ability to fly in regions where the C-130 version of the Compass Call was not able to perform. So now you have a lot more of this capability. What's changing is the way the warfighter is looking at EW. Renaming the EC-37 to the EA-37 was a deliberate step by ACC to say this is an attack platform. EW is now a weapon. It's no longer something that's an aftermarket that we've thrown on a platform. Whenever we did mission planning with weapons, we'd say, what is our desired weapons effect, and work backwards. Well, we are doing, the Air Force is now starting to do that same thing with electronic attack. What is our desired mission effect? And let's work backward and find out which platforms, which attributes we need in our platforms to achieve that desired weapons effect. So what we're doing is we're moving away from the platform-centric, I need F-35, I need a Compass Call, and I need F-22, to where I need something that can affect this portion of the electromagnetic spectrum. I need something that can affect this portion of the electromagnetic spectrum, so I can get to a point where I can employ a weapon. And that's everything from our 5th gen and B-21s, all the way back to what can we put on our large aircraft to get our tankers to be able to move just 100 miles closer. Enough of situational awareness so we're willing to go 100 miles closer can do a lot on what weapons now I need to procure for my platform. So it's really not the capabilities are new, it's the amount, the capacity that we have of them, and really the way the warfighter has changed the way they're looking at electronic attack as a weapon.
So I look at all the assets that Chris just mentioned as parts of an orchestra, right? You've got the big kettle drums, right? And then you have very, very fine instruments like a Stradivarius or an oboe, and they all need to work collaboratively within the electromagnetic environment. They need to be battle managed in real time to provide those desired effects. So we've always talked about the many small, smart, and connected versus the few and exquisite. And it really shouldn't be that. It should be the many small, smart, and connected working with the exquisite in a collaborative fashion, all orchestrated through some AI-informed ENVM architecture, such that you can prosecute the environment in real time and accomplish the mission.
Yeah, thank you. Okay, team, that wraps up our pre-prepared questions. You're now going from the frying pan into the fire. And we're going to open it up to the audience. And so, same ROE as before. If you could please raise your hand, I will identify you. Please wait for the microphone. Identify who you represent, your name, and then your question. Any questions? You've completely wowed the entire crowd. Gonzo.
Colonel, you mentioned cognitive EW. It's a topic I've been very interested in. Mark Hunsinger, Petro Institute. What are some of the most significant barriers to delivering cognitive EW to the warfighter? Is it technological, like computing power, AI, or is it, frankly, resources, budget? What are some of the barriers that we have to overcome?
So I'll give you maybe a two-part answer on that one. So for the 350th Spectrum Warfare Wing, the barriers for us is we just don't have the resources yet. You know, I like to articulate that as we're building the airplane as we fly it. So a lot of the labs that I need to get after waveforms, I don't have yet because my elegant MILCON solution is not in place yet. But that's not going to stop me. I'm already looking at options to bridge that gap with mobile labs that I can later use for COOP capabilities to get after the problem sets that we face today. It comes infrastructure. I just don't have a lot of that infrastructure yet. It's coming, but we don't have it yet. Personnel, I mean, to put the right people in place to get after these difficult problem sets, they require a pedigree and an acumen that we're still building. Folks that, like I have my own chief engineer, he educates me every day on the shortfalls and the things that we need to do to get after these difficult problem sets. So I will just tell you it's funding, resources, infrastructure, and personnel are some of the barriers that I've just encountered in my short time in seat. But I'll also tell you there's a standardization issue because not every pipeline, because we supply information to over 70 platforms. Not every pipeline has the same structure. So what may work for one particular platform does not work for another. So I'll give you a case and example. We produce an emission data file, but if it has to go through a proprietary source, now they have to rewrap it in order for it to go into that particular aircraft, whereas I may have a more legacy system, whereas I push it through and it can go through pretty fast. And that's where I get when I talked about going fast. We have seen where we can go fast, but there are areas where there's policy barriers, dissimilar structures, manpower intensive processes that do slow us down. And that's what we're highlighting right now so that we can go faster. And I do believe we can. It's just we got to remove some of these barriers that are in the way. Some of them are man-made, but some of them are policy, and we have to adhere to them unless there's a lessening on the restrictions.
Hi, Michael Morrow with Breaking the Fence. Colonel, I wanted to ask you about just kind of the threat landscape. There's been a lot of concern that Russia and China are ahead in EMSO. And I wanted to ask you, could you just kind of lay out where you see the U.S. relative to China and Russia and what either getting ahead of America's adversaries or staying at pace with them looks like when it's such a cat and mouse game?
Yeah, so our adversaries, they've definitely had an opportunity to, while we were focused on terrorists and violent extremists, to build up their apparatus and their capabilities. They've watched us and they've seen how we conduct war. They see how we roll back IADs, all these different capabilities. And so they've developed capabilities, as I alluded to earlier, to counter what has traditionally been an advantage for us in the spectrum. So while I don't believe we're behind, because we do have some fantastic kit out there, but I think we need to go faster for how we're going to fight in the spectrum. And that's going to require is funding and the resources to develop those capabilities. As I said earlier, I don't necessarily have all the professionals, but we're developing the professionals that are focused solely on that EMSO fight at a peer level. That is something we haven't been focusing on because we've been dealing with violent extremists and terrorists. But some of the innovative ideas and the things that are coming out from this team alone, being focused on the EMSO fight and how do we dominate in the spectrum and win, is something that I'm definitely pretty excited about because I see some capabilities that are coming online. I see the synchronization of thought and where we need to go with capability that makes it promising. And I will say, while we're not behind, we do need to go faster in developing the capabilities that we need to fight the way we're going to fight in the time and place of our choosing.
Tobias Nagley, Air and Space Forces Magazine. So I'm interested in, I'm not going to ask whether the spectrum is a domain or not, but I am curious, you need a seat at the table to get the resources that you need. AF cyber is being elevated. Should there be an AF EMSO that is getting a greater focus on your mission set?
So for the 350th Spectrum Warfare Wing, I will tell you the 350th is just one of the answers for the United States Air Force and re-optimized for great power competition in the electromagnetic spectrum. Where specifically our mission is to go out there and deliver the cutting-edge, game-changing capabilities that we need to operate within the spectrum, to make sure that the Air Force component commander, as well as the Joint Force commander, they have the tools that they need to go out there and get the job done and enhance the warfighter so that they're lethal and survivable in that battle space and come home. So while it may not seem like it, we are moving out, and we are actually working with our cyber brethren, our space brethren, to get after some of these difficult problems within the spectrum, because the spectrum is inherently cross-functional across all domains. And that's how we're getting after it. We're getting after it pretty aggressively. Like I said, well, the 350th, was born in June of 21. We've been getting after this problem set pretty aggressively. And while I may not have the elegant solutions that I want, I'm still putting in place some of the things that I need and the tools that we need to get after this problem set and win.
Okay. If there are no further questions, gentlemen, please, everyone help me thank our panelists for elevating our conversation today. Yeah. Thank you so much. And next time I see a fighter pilot, I'll give them the bad news that it's not about dogfighting anymore. It's about data fighting. I'm sure they're not going to like that one.